Welcome to Course B, Lesson 4, Programming with Angry Birds. Again, the purpose of this is to outline computational thinking concepts, powerful ideas, and critical thinking strategies, and to model some pedagogical strategies. And at the end, we will debrief. The 3 lessons we're asking you to teach were Lesson 3, Sequencing with Angry Birds. This one is Lesson 4, Programming with Angry Birds. And next we'll do Lesson 5, Programming with Harvester. Again, we're going to reinforce some of the same computational thinking concepts and powerful ideas that we did in your last video, but we are also additionally going to add loops and pattern recognition. And again, we'll be talking about the same critical thinking skills: observing, predicting, planning, problem solving, looking at cause and effect, and comparing and contrasting. And we'll be using pedagogical strategies of student-centered learning, giving students time to play, to think, to experiment, to modify, to run, but we're also going to provide some direct instruction and allow students time to problem solve. Now I'm going to model some of the lessons for you. So we are going to do Course B, Lesson 4, Programming with Angry Birds, and I want you to notice that this is a diamond shape. So the diamond shapes are videos and the circles are activities. And I am going to start us with Lesson 4, Part 2. I encourage you to watch the video on your own. And the video is on pair programming, where one student is the driver and one student is the navigator. So the driver gets to touch the keyboard, but the navigator gives instructions. So I encourage you to watch that video, to put your students in pairs while they work through this activity. And then walk around and monitor that the navigator isn't taking over the keyboard, because the navigator is not supposed to touch the keyboard, only to give feedback. And what this does is it teaches students that critical communication skill, ways to verbalize what they're thinking. So here we are, we're on Lesson 4 and Part 2. Here's my workspace, and the first thing I observe is that there is no code in my workspace, but there are many tools in my toolbox that I could use, and I see that there's a new one here. It has a repeat. I'm going to look at my play space. Again, I'm still using my critical thinking skill of observation. I know that I want to get Angry Bird to the pig. Compare and contrast. How does this play space look different from the one that was in Lesson 3? Well, in Lesson 3, I had boxes lining my pathway, and here I'm sort of out in the open. What do I think that's going to make happen? I think it's going to be a little bit more difficult to count the spaces to get from Angry Bird to pig because of the layout of the play space. But there's no code, so I need to write it myself. And before I do that, I want to come up with a plan, and I'm going to decompose this. I'm going to break this big long path down into steps, smaller problems. So I'm going to plan, and I'm going to say, here's 1 step, here's 2 steps. I think that Angry Bird is going to have to take 3 steps, and he's going west. So I'm going to take 1, 2, 3. Remember, encourage students to play. I still have my run. I have my step function, so I can decompose this. I can break it down into steps. This is my algorithm I have just run, and I have a sequence of 3 steps. This creates my algorithm. When I hit run, that's a program. So I'm going to go step by step. I could hit run. Let's compare and contrast. How are they the same and different? Both of them get Angry Bird to the pig. Run gets him there in one fell movement, whereas step, it decomposes the problem, so I can, and a benefit of that is I can see if there's an error. I can see right where the error is. So step, step, and step, and Angry Bird gets to the pig. But I want to replay this. I don't want to be done because there's another construct here I want to talk about. I've got this amazing algorithm, but and I have this sequence. Do I see a pattern in this? And I do. I see that I'm going west 3 times, so I'm going to reset this. Let's make an observation. I have a repeat button here. How can I use that? Drag it from the tool space to the workspace. I'm going to click it in when run. I am going to say that Angry Bird can go west 3 times. I'm going to take this. I like my workspace to be clean. I don't like extra code mucking it up. So I'm going to throw those away back into the trash. Let's predict. I have a new algorithm now. It's a little bit different. Notice that I can actually change this. I'm going to leave it 3 because that's how many spaces that I need Angry Bird to go, but I could make him go 2, I could make him go 10. When I hit run, he's going to get there in one fell swoop, I hope. Let's see, I predict that he will. And Angry Bird is there. I'm going to let you continue playing now. So we're not going to do 3, but have your students do 3 on their own. And remember, they're pair programming. So now I'm going to go to 4, which is skill building. Together, your students and their pairs can talk about this. Let's do our observation. Here is my algorithm in my workspace. I see south, south, south. Do I see a pattern there? I do. Now, this is where your navigator can say to your driver, I think that we should pull this code apart, use the repeat button, and before I get rid of my extra code here, I think I'm going to try this to see if it works. So if I look at the instructions, it says, can you add something to the end of this code? So I haven't necessarily done anything wrong. What I've done is right. So I'm going to get rid of this unused code over here. And now I have to come up with a plan. I'm going to go 1, 2, 3. And then what has to happen? Angry Bird, I think, needs to turn left and go west 1 space. I now have a new algorithm. It's my program. And now the driver can decide. Let's decompose this and see what it looks like. 1 step, 2 steps, 3 steps. I'm going to go back to replay. So whenever you have something that repeats, what you have is a loop. So a loop means you can use the repeat function. You've seen a pattern, there's a loop, you can use the repeat. And also, if you see a repeat button in your code, what is that indicative of? It's indicative of a pattern. It's indicative that there is a loop in your program. So I'm going to let students do 5 and 6 on their own, but when I get to 7, I want you to notice there's something new about 7. 7 is a challenge puzzle, and obviously everybody wants to do the challenge puzzle, so you are ready. Again, I'm going to make an observation. Here is my workspace, here is my toolbox, here is my play space. Look, I don't have a step-by-step function in this one. I have 2 hints if I need a hint. I can play the audio, I can read the instructions, but my challenge, what is the challenge? What makes this more difficult than the puzzles that we've seen in the past? Let's think about it. So I would say there's these boxes of TNT, and the other ones didn't have boxes of TNT. So how can we get Angry Bird around the boxes? So I can do that by, let's see, Angry Bird probably needs to go north. I'm going to decompose this and I'm going to go step by step. He's going to go north 1. Here's my plan. Again, you've got your drivers and your navigators working together. The drivers are dragging the code over. The navigators are giving their opinion of what code needs to be there. So then Angry Bird needs to go 1, 2, 3 spaces to the right. There's 2 ways to do that. What are those 2 ways to create an algorithm? I can either use 3 go east boxes, or when I create my algorithm, I can use the repeat block with 1. And again, I want to keep my workspace clean. So here, I'm going to start over again. I'm going to decompose it. I'm going to go north. I'm going to go east, 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 and then I think I need to go south 1 time so that I can get to the Angry Bird. Predict, what do I think is going to happen? I think he's going to get there, so let's hit run. I'm going to go back and say, try again. This was great. Angry Bird got there and avoided all the TNT. If something went wrong, it's not a problem. Your driver and navigator just need to work together to debug their program. But one of the things I want to know is, I'm kind of curious. I know it's not cool, but what happens if Angry Bird hits the TNT? So let's say I want to know what that is. I'm going to intentionally run Angry Bird into the TNT. And to do that, I think the easiest way is just to have him go east. What do I think is going to happen when Angry Bird, let's predict, hits the TNT? So the cause is I hit the button, Angry Bird moved, he hit the TNT, and the effect is he disintegrated. 8 and 9 the students can do on their own. Going to 10, you're going to see a slight difference here. Look at this. This is very wide open. Let's observe our play space. There's nothing. There's no boxes in here. What I would encourage you to do is not get to the pig just one way. Who can find, working with drivers and navigators, 3 different ways to get Angry Bird to the pig? Let's look. Who can use the most code when getting Angry Bird to the pig? Who can use the least code when Angry Bird gets to the pig? Remember, you can use your step function to decompose this really big problem into three smaller problems. You can also make a plan. Make your 3 different plans and draw them on a paper before you start dragging and dropping code from your toolbox into your workspace. Again, the idea here isn't who can get there the fastest. The idea here is to explore the different things you can do with the code.org programming. And remember that kids can always look at the code that is behind the boxes. So as you move the code over and click it together, we can show the code to the students. Compare and contrast. How is the show code the same or different from the blocks that we drag and drop? Next, I'm going to debrief with you. So let's debrief. What did we do in this lesson? We talked about creating a sequence, a list of steps to help Angry Bird get to the pig, but we also made some loops. We saw some repeating patterns. We recognized them. We used the repeat button and we created a loop. We decomposed. By decomposing, we decompose when we use the step function, right? When we look at this great big problem, how do we solve it? And we go, hey, let's not look at it like this big overwhelming problem. Let's take it step by step. We recognized our patterns, we wrote our algorithm, and we fixed problems when we saw them. But we also thought critically while we were doing this. We did observations. We didn't just zip through the lesson. We stopped and we looked at the code that was in our workspace. We observed the code that was in our toolbox. We looked at our play space. We compared that place and contrasted that play space to previous play spaces we saw. How was it the same? How was it different? We talked about cause and effect. What happens when I hit run? What happens when I hit step? We solved problems, we made plans, and we predicted what was going to happen when we hit run. We also used some pedagogical strategies. So we gave direct instruction while still allowing students autonomy and experimenting and playing with the code on their own. We had them predict, we had them modify, we had them make things, we had them recognize what the problem was, and we had them devise a solution, and then we had them execute their program so that they could successfully accomplish their tasks.